All right, this is chapter 14, lesson 5. I want to review, when do we have holes in the graph? And when there's a hole, it's called a removable discontinuity. Continuity. All right. But then we have vertical asymptotes. And then we have horizontal asymptotes. All right. I'm just going to put VA, give me a little more space. Vertical asymptotes, horizontal asymptotes. Okay. Only when we have a hole in the graph, it's a removable discontinuity, and there is a limit. It's only when you can cancel factors. 5, Paula. This is a hole in the graph. A limit exists. Okay, so we're going to call this f of x. What is the limit of f of x as x approaches -1?
4.
You eliminate it, you plug it in here, and it's 4. The graph is going to behave like whatever's left over. That's how the graph is going to behave. All right? And you can find your y-intercepts, you can find your x-intercepts. At your y-intercept, the value of x is? At your y-intercept, the value of x is?
Wait, y-intercept?
Okay, I want you to listen.
0.
Yes. Listen. Where the graph intercepts the y-axis, the value of x is 0. Where the graph intercepts the x-axis, the value of y is 0. Got it? All right, so you could get your x and y intercepts from this. You make x equal to 0, you get your y-intercept. You make y equal to 0, and you get your x-intercept. We could graph that, all right? Now, where do we have vertical asymptotes?
Whole of the, not whole, that 0 of the denominator gives up 0 of the numerator.
That's a hole here at x equals 2 is a vertical asymptote. All right, so at x equals 2, gonna be a vertical asymptote, right? So you'd want to know from the left, that's why I've been talking about continuity from the left and the right. From the left, what happens to the graph? From the right, what happens to the graph? All right. Now, does anybody remember the rules for vertical asymptotes? What do we look at for horizontal asymptotes? We look at the degrees of the equations. All right. So we look at the degrees, just plural, of the equations. The coefficient, yeah, the degrees of the equations. All right. When the numerator is less than the denominator, so we have x squared plus 3 over x cubed minus 5. Numerator is less than the denominator. That's a degree of 2 over a degree of 3. You have a horizontal asymptote at y equals 0. All right. When the numerator equals the denominator, it's an n, Numerator equals the denominator. It's lead coefficient over lead coefficient. So there's a horizontal asymptote at y equals 2/5. All right, numerator less than denominator, y equals 0. They're equal, lead coefficient over lead coefficient. When the numerator is greater than the denominator, there's no horizontal asymptote. It's a different type of asymptote. It's a parabolic asymptote. It's some other kind of asymptote. It's not linear, horizontal. All right, some other type of asymptote. All right, so these asymptotes, we may have vertical and we may have horizontal asymptotes. But we're still going to look at, our zeros, and we're going to look at what happens as we approach the vertical asymptotes. Because what happens as we approach the vertical asymptotes are going to be like this or like this. It's either going to go to positive infinity or negative infinity. All right? So our asymptotes and our holes are going to matter. Let's try to walk through a couple of these examples. So look at me on page 949. Now we're going to look at limits that involve infinity. Remember, infinity is not a number, it is a concept, right? It's a quantity that continues to grow and grow and grow. All right, so it was important to remind you of this before we run through this chapter. We'll try to get through a couple of the examples and maybe we'll work the rest on Tuesday because today's Thursday. All right, so here's my function. F of x equals -5 over x to the 4th. And it wants to know the behavior as x approaches 0. All right, well, we're going to look from the left and the right. From the left, and then we'll look from the right. All right? And so it's undefined at 0, right? You agree with that? Undefined at 0. All right, so what happens as we approach 0 from the left? All right, so I really need your help with your calculator. So let's look at -0.001 and -0.01. Somebody do one of those.
I got the first one.
Okay, somebody get the second. All right. Somebody do 0.01001. There should be 2 zeros there. And 0.01. When I raise a decimal,
I got -5, very, very large number.
Yes, just -5 with a bunch of zeros.
negative over here. So you're saying negative infinity. Huh? What do you get over here?
For 0.01, I got -5,000 something.
So
That's what I-
negative infinity. Because what is 0.01 squared?
It's a positive.
Tell me what this is squared.
It's 1 e to the
-0.0001.
Look, what happens when I raise a decimal to a power? It gets smaller. So I'm raising a very small number that's going to get very much smaller. 5 over a number that's getting smaller is bigger, right? It's a big number. Okay, look. here's the negative out here. 5 over, as this number gets smaller, this value gets bigger, but because it's negative, it's going to negative infinity. So it tells us the behavior. Got it? So from the left and the right, it's both negative infinity. The limit from the left and the right is negative infinity. All right, number 2. Let's quickly do number 2. Now our function is 8 over, let's factor that denominator. What's that denominator factored? X minus 4 times x plus 2. There we go. So, what do we know happens at negative 2? At negative 2, at negative 2, there's a what kind of asymptote? There's a vertical asymptote. That is correct. There's a vertical asymptote. All right? Huh? All right. What's the degree of the numerator? 0. What's the degree of the denominator? Squared. The numerator is less than the denominator. Where's our
Wait, I'm just sorry.
numerator of a constant is 0. I mean, the degree of a constant is 0.
What is it when it's 1 then?
X plus 2. A linear.
Because if you multiply those out, try to say it's squared.
This is x squared. Second.
Okay.
All right, constant is 0. So there's the x-axis is a horizontal asymptote, right? All right. It's never going to cross the x-axis because the numerator cannot be 0. Y is only 0 when the numerator is 0 and the numerator is a constant, okay? So we have to ask ourselves, what happens ever so close to negative 2? All right, so we can plug in negative 1.999. Somebody do that. And, okay, that's going to be the left. And negative 2.001. All right, let's just do those two. I would typically do more to make sure I've got a right answer, but. So this is from the left, this is from the right.
Okay, for negative 1.999, I got negative 1.00024937. Basically negative 1.0. What is the negative 1?
I got 1,000.
You should have gotten a really,
I think I was there.
For the negative 2.
here you should have gotten a really big negative number. And here, so this should have been to negative infinity, that should have been to positive infinity.
Okay.
Okay, let's look at it. All right, so this would be 8 over, this is going to be like negative 6.0, 8, Paula. 6, you're adding. Negative 6.001 times negative 0.001. That's going to be a really small negative number. That's going to be a really small positive number. So that's going to be positive. So 8 divided by a very small positive is going to give me a positive infinity. Okay? I mean, I can just think logically through this. All right, so that's going to be the positive infinity. All right, so I'm thinking here, it's gonna go this way, because it's gonna go to positive infinity. Now, huh?
How big does the number have to be for you to make it infinite?
Okay,
'Cause
well,
only got one
I know that this number is going to have 6,
That's what I got.
what? What'd you get?
1,333. Does that count?
Yes, that counts. Why? Because, wait, over here you got negative?
For the negative 2.001.
No, it should have been a negative times negative, you should have gotten a positive.
Yeah, we're
Yes.
talking about
We did.
negative 1.99.
Oh, we
No.
did.
Okay.
2.0.
So you should have gotten a big positive number.
Yeah.
Well, no, I got.
And it's gonna keep growing. Yeah, we typically don't graph like 1,000. And here, when I have negative 1.99, this one is gonna be a negative what? 5.999 times a positive 0.001. So now we're gonna have a negative. So now this one has to look like this. Because that's a small negative number.
Yes,
8 over a small negative number. Okay, everybody listen. It's a small, big concept. It's a little, big. Denominator little, the result is big. Always when you divide by a decimal, your number's gonna be bigger. Always, okay? It's a little big concept. You just have to decide, okay, we're going to negative infinity here, we're going to positive infinity here. All right, we'll stop.